Hello, hello, hello. Welcome to the 31st TouchDesigner Roundtable Berlin. I'm very happy to see so many of you cramped in this little room. And we're very thankful to Field.io to have invited us and to provide food and drinks for our estimated audience. Yeah, that's you. Yeah, very happy to see so many long-time visitors and so many new-time visitors. And of course, Field.io is going to start the evening with a presentation introducing their studio. It's going to be introduced by Chan Choi, which I learned just flew in from London. Thank you for that, coming all the way. And Riccardo Torresi, who's a regular with the TouchDesigner Roundtable and also has presented his personal art projects before. And without further ado, I would like to give the microphone or the stage to Riccardo and Chan.
I guess we should do this, right? Thanks a lot for coming. All right, sorry. No. What was the... Sorry. Now. Okay, thanks a lot for coming. A lot of nice faces here. It's kind of overwhelming to have all of these people. So yeah, we will do tonight a little presentation which is a bit different from what we normally present to customers, obviously. Showing some of the projects in which we used TouchDesigner and also some explorations and some experiments that we did over the past years. So yeah, first Field. Field is a global creative and design studio. We've been around for about 14 years now. Having a team of around 30 digital artists, CG, 3D artists, producers, directors all over the world. So yeah, what we do is we break down complex narrative into visual stories and interactive moments and experiences. So yeah, we worked for big brands, but also from smaller agencies. In order to facilitate their communications. So we have two studios, the main one which is in London, and this one in Berlin since 3 or 4 years now. So a big part of the team is also around Europe. So we have a lot of people working remotely. What we like is cooking. So one way to unite is through food. We like to cook together. We do this a couple of times a week here in Berlin and also in London. And we also got inspired by food. This is Margot, our colleague, which is there, cooking some nice noodles and also doing some exploration in Houdini with the same kind of aesthetic.
Hello. So we also love to travel a lot because our company is so remote that we like to come together once in a while and get inspired. So we go to places from Hong Kong to Seoul to valleys in America, just a way to open up some wonderful artistic inspirations and explorations from us. And from this, we create immersive digital and physical spaces that have the power to both listen and speak. So this is how we inspire audiences and bring brands to life.
So yeah, a big topic in our research and also our process is nature. So tonight we will show you some projects in which we got inspired by nature or natural phenomenon. The first one was an installation we did for Envision. Was a media wall. Envision is a company, a Chinese company dealing with energy. So they had their new headquarters in Shanghai, which had this very big wall, media facade, which is was around 40 meters by 8 meters, so very massive. And the interesting thing was that actually the LED wall was covered by this frosted glass surface that was diffusing the colors very well. Because the LED wall itself was a super low resolution, was 626 by 136 pixels on 40 by 8 meters, so you can imagine that some sort of diffusion was really needed. So yeah, for talking about the process, we started by observing and analyzing natural behaviors, and this meaning from birds flying to whales swimming or fishes to jellyfishes. And we use this as a kind of driving force to produce some first explorations using videos from these creatures to drive colors and displacement effects in TouchDesigner. So yeah, one big part of the concept was transformation of energy. So we started getting inspired by some other phenomenon like light, water, or some reflection, refraction phenomenon. And we started creating some very small animations that we then tested to the wall with the Chinese team on site. We actually never seen the wall in real life, which is a bit sad. But yeah, we could continue by just streaming camera footage to test this on the wall.
So as you can see here, we take a lot of images and we use the images that we take and manipulate them in TouchDesigner to make them feel more ambient and have this feeling of wind blowing over them. And we have multiple chapters that we would cycle through. For example, source of life, power of nature, life on earth, and we will switch them up and try to interpolate between these natural formations. So this concept, we had this sketch which we would show you because we think it's really nice, where we saw Mother Nature as a painter. And in this way, we decided to explore hand-drawn sketches by drawing them out and then exporting into Houdini and then exporting it into TouchDesigner to apply more fluid hand-drawn effects to it. For example, here you can see the line is exported in, and then we'll run simulations through it.
So yeah, the down right part is TouchDesigner. Here we exported some SVG files that then were running this kind of brush effect over the texture. So there were some parameters that you could change, like the dimension or watery effect. But yeah, these were some of the outcomes after some diffusion and some feedback techniques that you might know very well. We also tried with some human movements. But yeah, sadly, this was actually killed by the client. So we spent a lot of time on developing this, but they actually didn't like it. So that happens a lot, sadly. So here you can see the actual content, some of the content that we did project on the wall. There should be some sound. Yeah. So yeah, part of the project was also this purely generated soundscape. So the whole system was divided into chapters, as Jean said, and each chapter would have like a mode regarding sound. Yeah, this is part of the sound. We collaborated with Asako Fujimoto, which is also here, and she collaborated into a lot of different projects. Here you can see a simulation on done in Houdini on the facade, and here you can see the actual output on the wall, which, as I said, we still haven't seen in real life, unfortunately. So the wall had this possibility to be controlled remotely, so there was also a web backend interface that the client could use in order to change the content or the text or the sound that was going on the screen. This is a little sketch of the setup. So we had like this backend app on a backend server. We have a local router. The interesting part was that it was running through MQTT, so you use MQTT quite a lot through our projects, and this was the first time we used it in TouchDesigner in order to the backend app to communicate to the main machine. So here a bit about the patch. The patch was quite simple in the end. It was we put a lot of effort in making it modular, so you had like different modules and a lot of externalized components that people could work on without actually changing the main patch. Here a bit of the process. So we externalized a lot of toxes, and each chapter was loading an external tox. And also we worked a lot with GLSL and Python, so a lot of these were also externalized. So we had a team working on this project that was using GitHub and was just updating the stuff that they were working on. And this was actually quite smooth as a kind of pipeline production. And then, this is a bit of some screenshots of the backend, which was really, really like simple, rough, but exactly what they needed. So there was like this scheduler that where the client could schedule the video that would be displayed. It could also hide some chapters or change sound volume, put some text on the screen, and this is it for this one.
So we've been working with IBM for a while, and for this they developed an IBM quantum branch that dealt with quantum computing, and they needed a visual system to communicate these principles. So inspired by the 3 fundamental principles of quantum computing, we set about trying to communicate this in a visual way. For example, entanglement, superposition, interference. So it's pretty hard to visualize these sort of concepts as an artist, especially when you can't really see them, they're intangible. So we had to look to existing graphs and to science to try to explore how this might come about. For example, the Bloch sphere as a way to visualize the state of a single qubit in quantum computing. It's basically like a map that helps us understand where a qubit might be in terms of its quantum state. We looked at the first photos of quantum entangled particles showing a Bell inequality. Sorry if this is boring, but basically it helps us check if these particles are following the rules of quantum mechanics and other sorts of graphs. So meet the players. Over here you have superposition, which is basically a qubit's ability to exist in multiple states simultaneously. entanglement, a phenomenon where qubits become interconnected in a way where one instantly influences the state of another, regardless of the distance. And then you have interference, which is when qubits combine and their probabilities interfere, affecting the outcome of the computations. So here's some nice, sexy patches for you guys. This is the parameters network. So basically, we expose the parameters to control the UI and tweak the different states to see how they would interact. For superposition, you basically have a sphere comped with the depth map and then feedback and displacement and blurred to create lovely tail effect. And then for entanglement, we had spheres instance on the grid to create that bridge. And as you increase interference, the grid gets wider and it creates this bridge connection. And as for interference, we had a shader that we displaced. So having this custom generative tool was important because it sat at the heart of the brand visuals. It was a visual playground for us to explore the dynamic interplays of these states and to tweak and interpolate each other. And we made so many versions of these, too many. But it was a great tool to also give IBM for them to play and create their own assets.
So yeah, one part of the project was also creating a visual language for this conference they had in New York last year about quantum computing. For that, we had this idea of offering like some invites which were different from each participant that would attend. And the differentiation would be done by the location of the participant, essentially. So we took this concept of dawn, which is this moment which marks the beginning of twilight before sunrise. We thought that this was interesting visually because it generates also some gradients. We love gradients. So yeah, here you can see a first exploration. And then we were also interested by this light phenomenon of the sun. So we researched these halos, which are these effects that forms around the sun or moon when it refracts some crystal present in the clouds, essentially. So you have some conditions which these are more visible. And then this solar pillar, which is this kind of pillar that appears in some circumstances before sunrise. And then, as I said, we form these gradients based on the location and the path of the sun, but also on the climate zone of the participants. So we decided to give every participant a different gradient based on where they placed according to the climate and according to the sunlight. And these were some explorations in which, we used two different APIs, one for geolocation, one for basically one for latitude and longitude, and one for the climate zone. And we then produced this kind of images based on the time where these invites were sent and the location where the participant would be. This, you can see some more example of those. We also created some badges for the event. We finally went for this color grading, which was related to New York, where the conference would take place, and we created this animation that would reflect all of this, essentially, and that would go on the main stage. So this was an image from the conference. We also produced different assets for them that they used in their communication materials. And this was kind of a quick project compared to the other that lasted almost 2 years. This was maybe 2 or 3 months, or maybe a bit more. Yeah, so maybe you want to, I don't know, maybe I should continue, then you go. So yeah, we added also this part of explorations. It's what you can also see in the other room, some of them. So we also like to explore different techniques when we don't have deadlines or stress from projects. In this case, we thought that would be cool to create a sort of system to bring together London and Berlin. So we thought, okay, why not creating this virtual environment that would reflect one reality into the other reality, and it could run as an augmented reality app. Obviously, this was just some exploration. We didn't develop it so far, but this is all done in TouchDesigner. It was also a bit inspired by this work from Olaf Eliasson. So yeah, we created this kind of system that would use these 360-degree textures reflected on these geometries, and as you move the camera around it, it would display some of this effect all over.
Here's another different portal thing that we did, but perhaps in a more playful, colorful way. So we're trying to connect London and Berlin, and decided to have 2 live feeds that happen at the same time and interact with each other. So yeah, here you can see 2 live streams, me and Hugo at 6 p.m., way past our work hours, waving at each other, having a good time, from Berlin to London. Yeah. And so we use the OD camera for depth, and as well media pipe library for segmentation. And yeah, pipe both of them in, and pretty much the whole lesson of all is just have a good time. This is another sort of off-cut project we did where we wanted to have imprints of energy. We visualized this room where visitors would come in, and they'll walk up to the screen, and their portraits will be printed temporarily just for a second. So they're inspired by Lumen heat maps. And we were thinking of a scanning mechanism. So you scan the portraits and you see the particles of the person move around. So here's the portraits, some more examples that we did. So here is the same principle but different geometry. We did this for spaces, this room, and it was nice to see how it sweeps and affects the entire geometry. More examples here. We also played with nature, scans of flowers, always very beautiful to see. And yeah, so we cycled through this and show how you switch from a rose to a portrait of a person, and then eventually a scan of a room. There you go. So when you come in, you might have seen a screen that showed like a project with a leap sensor for Randori. So while developing that, we prototyped a lot in TouchDesigner before bringing it into Unity. And here are just some of our tests. As you can see, the hand over there.
Yes, so we explored a bit of some techniques using the leap sensor. Actually was a good learning to start from TouchDesigner and then translate this into Unity. So yeah, what you see here on the left are some TouchDesigner exploration, and on the right are some Unity. And as Jan said, you can experience the work in the first room. Yeah, this was done last year also with some of the people in this room as well. Another exploration that we did was creating a game. So we wanted to, actually this is not, the output is not TouchDesigner, it's Unreal. But it was a good case to test this exchange between Unreal and TouchDesigner. So here we had like this game environment built in Unreal, in which the user could play with this virtual nature, could search and collect objects, and would also produce sound while walking into the environment. So yeah, we used the decals in Unreal, which is this technique where you can apply basically a texture to a geometry and you have this diffusion which is driven by the texture itself. And we created this, this is also a soundscape done in Unreal this time, but we essentially produced these textures in TouchDesigner and then we streamed them to Unreal and the effect was quite nice. So definitely some potentials, but it was purely an exploration, sadly. So in the end it didn't become a game itself, but it was nice to play with, definitely. We added this last part because we know that .simulate is gonna present. So we also explore stream diffusion. Here you can see some example using this fluid simulation from our colleague Bruno Imbrizzi. Maybe some of you knows. It did a lot of good stuff with fluid simulations in TouchDesigner, and he helped a lot on a lot of projects. Sadly, cannot be here tonight, but maybe one day. So yeah, here we translated this fluid simulation inside stream diffusion with different prompts. Maybe you might know the technique. We also tested it on types and different fonts and letters. And there's definitely a lot of potential here, so I'm very curious to see the next presentation. From .simulate, and yeah, thanks a lot for coming. Maybe there are some questions. So maybe we should stay.
Yeah, thank you very much for these insights. I would start with the first question, and it's, I mean, there's a very distinctive style, I would say, to Field, very clear art direction, and I wonder how is that implemented? Like, is it like a top-down approach? Is there like one person who, or is it like the whole team has inhaled it, and that's how you always end up in gradients? Which I really like.
This is so some of it was driven also by the client, so the client also plays a role there. But yeah, somehow we ended up always with gradients. I guess people love gradients and they're simple. Regarding the I mean, I have to say we have quite a bit of freedom in terms of like style creation. Then we have contribution from many members of the team. Yeah, I would say this goes from like the designers to the developers to the head creative director. Obviously, the creative director always selects and composes the presentation for the client. So I guess the big role is also a creative director. Paul is here. He directed the Envision project, so I guess that's also was a really big responsibility. But yeah, it's always a kind of balance between forces, I guess. But I would say it's quite free, the flow, in terms of visual style, I would say. Then there is this selection process that happens after. I don't know about your experience. Maybe you also want to answer, Jen?
I've inhaled it deeply.
Good answer. If there are questions from the audience.
Hey, thanks for the presentation. You mentioned for the project you did for the China client with the facade of the building, it took like 1 or 2 years.
I'm actually longer, I think.
Longer.
Yeah. It was a special client.
Right. If it's not like too confidential, what took so long? Like, what are the stages of the project roughly?
It was a lot of like, I don't know, decisions. Maybe Paul can tell actually more because he was the one facing the client all the time. So good effort. Yeah.
It was only for the last couple of months facing the client. But yeah, it's like maybe.
Yeah. So for this project, I think what is interesting is that also like these projects, they're creating images of a brand, of a company. So that can take some time because like it's not only about like what you deliver and how fast you can deliver it. It's also really about the journey. And in most of these projects, the clients they try to find themselves and what they stand for. And I think that's what's happened there. But yeah, I think in the end, it was a really good project. Yeah. So it's the process. It is a lot of entertainment as well for companies like that because I guess with the beauty that we create as artists and designers, I think it's also entertainment for them and finding themselves. And how do we look like? How would you represent like an image of yourself as a company? So yeah.
Hello. Thank you for your presentation. Really nice. I really like the IBM quantum stuff, and I was wondering how you, or if you did collaborate with scientists, and how you come up with those findings about entanglement and superposition and all that stuff.
Yeah, I mean, we did exchange with scientists. The thing is, they are really expert on describing a process, but it's really hard for them to visualize it with simple images. And that was our role. So yeah, we kind of got into the topic, which was really complex. Then also we found some of these images, which were also shared by them. But it was a bit of a ping pong with them to understand how the actual work, what was the behavior, what kind of motion we could create out of this very complex system. So yeah, we exchanged with them, but yeah, it's really hard for them to visualize this kind of stuff. The visual part was up to us, and it was always we always tried to keep it very simple and minimal, because being so complex physically or theoretically, we thought that would help a lot to have some really simple visuals to communicate those. So yeah, I hope I answered your question.
Nice, you did a very good job.
Thanks.
One last question. Now, then I'm curious. You said you do the research in TouchDesigner, and then you brought it to Unity. Is there a specific reason why you take one thing then to the other technology?
So I guess, I mean, you want to answer, Jan, also? I don't know.
I guess it's pretty fast to prototype things. It's very quick. Whereas like some of software is like Unity might take a lot longer, especially if you're not used to working in the environment. So it's like dirty, rough sketches. It's always good to visualize stuff.
Like also the two projects that we showed, one of them, the Envision one, we had a very small resolution. So the kind of, we weren't expected to deliver a realistic content. So it was totally fine to use everything that was in TouchDesigner. The IBM project that you see there, it's a bit more complex in terms of shaders, of global illumination, ray tracing, all of this kind of stuff. So we would really like to, from the TouchDesigner, to develop a really nice render engine. Like really look for that in order not to move this project to other softwares. but of course, Unity and Unreal, it's like it's quite good in terms of high-end graphics. So there's always like depends by the expectation of the project. If it's simple gradients, you totally good with TouchDesigner. But if realistic rendering where you need more power, then unless you have a nicer rendering in Touch.
Your words in God's ear. And what in God's oar. Yeah, I think
maybe another question.
another question.
So, because of the music, and I think that's quite interesting from the Envision project. That was like it was like a procedural symphony, and it was created in TouchDesigner. So how did that go? I think there's like a symphony created in TouchDesigner. That's interesting.
Yeah, it was interesting. Maybe we should ask Asako, which is here also. She composed the symphony. But I think what we experienced, it was some little glitches, or wasn't so good to deal with sound in real time in TouchDesigner. Let's put it like that. In the end, we end up rendering some of those. But of course, there's space for development. Also, it was the first time we did a sound-generated piece in Touch. So I guess there's always some room to develop better things. Let's put it like that. Or I don't know.
Well, thank you for these insights. I think we have to get in our beloved break, because we're going to be back at 9 with Christian Riekoff, who is going to introduce Fuse to us, which is a new library for V4. And we're very curious to see how that implementation works, how that workflow works, and we're very happy that he's going to be with us. Thank you again for this wonderful presentation and this looking back behind the curtain.
back. Please, everybody, come back in. Have a seat. Yes, from my side, yeah, we're waiting one more minute maybe for the rest to join back in. All right. Welcome also from my side. I assume that most people in this room don't know me. I'm Stefan's partner with the NodeInstitute, and I also guess that most people don't know before we started the NodeInstitute in Berlin. Node has a longer history coming from Frankfurt, and we started in 2008 actually in Frankfurt from the vvvv community. And I have today the luck to be the bridge maker, and I'm David. I'm responsible more or less since I have Stefan next to me who does these fantastic programs with all of you guys. I'm the one filling the vvvv program, and today Christian Riekoff is here, one major contributor to the vvvv community, and maybe you can put in the chart what you gonna talk about. You can then find on our website. There's the intermediate program for vvvv starting soon. Yeah, so maybe get a photo of this, direct you to the website, and but I guess Christian, you will tell us more about Fuse, a library that yeah, making waves in the at least vvvv world yet. So have fun.
Yeah, hey, really nice to be here at Field Studio, so big fan of your work, and also nice to present here before the TouchDesigner audience. So even though I'm not using it, I look a lot of stuff on it on YouTube and find tutorials really inspirational, and watch pretty much of the last roundtables here. Yeah, I'm stoked to be here, so thanks for the invitation from the NodeInstitute. Yeah, so I studied media programming and media art, so I'm both an engineer and artist, and as such interested in building visual systems, like for what they do, creating art, but also just for building them themselves technologically. Yeah, and 3 years ago I started this endeavor, Fuse, because I wanted to kind of create a good visual programming system for shaders. I think that was missing, and before seemed to me like a good playground. It brought already a lot of capabilities. I needed to build this visual language. It was already there, and I could put the shader programming on top. And it looks like there was a gap for that in the V4 community. So I picked up there, and since the last 3 years, I and other contributors developed this framework. So before I begin diving into it, it will be pretty hands-on, and I will do basically patching, and by doing that, show you the possibilities that you have with Fuse. This is my Instagram site, just to get a kind of overview on what is visually possible, because for all the rest of the talk, it will not be about visuals, but more about patching and understanding. So this is a particle system. This is some particle system with feedback texture and kind of domain repetition. This is ray marching. Yeah, a terrain with some grids on it, some other ray marching. So these are from the November thing. So ray marching is a really good thing, and this is also something I will show today, how is ray marching done, how are particles done with Fuse, and especially also how they integrate. So this is for transparent ray marching. Another terrain. This more, maybe a more advanced particle system, like bringing lots of stuff together, different kinds of particle system in one visual. Okay, so let's dive into it. So here we have the VL window. I will check if it's big enough, yeah, so that everyone can see anything. So basically, Fuse has different levels. The first level is really being as complete as possible visual programming language to create shaders. And just to get started, and I really will be on this minimal level only for short, just that you understand here what you can do. So in here's the text chord level. So you already see like a preview here on what it looks like. And now you can just patch. Basically by doing so you write a shader. So here we have the output from before again. Can you zoom in? Yes, I zoom in. Is that big enough? Yeah. Okay. So and now you can scale stuff, yeah. And now, for example, I can add a sinus operator on top. And basically what I do here is the shader is recompiled every time. So also the preview that you see here is a shader that is applied on a quad so that you see a preview. And every time I do this here, I create a new quad internally for previewing it. And also the shader to this level gets compiled. Yeah, and these are like really lower level operators. So this gets translated to a multiply. This gets translated to calling a zine function in the shader. So these are like low level operators, but there are also higher level operators, like a noise, for example. So we could use this noise here, put this in, and then get this noise output based on this repetition. And yeah, maybe something else we can do is apply some domain distortion with another noise. So we create a 2D vector noise, add this on top. Again, we can preview directly how the noise looks like that we have here. And then we apply this in here. Yeah, and now we have created this domain distortion output. Yeah. This is now just on previewing, so this helps to kind of patch those kind of pipelines. But you can put this graph now into a shader that you could apply on a mesh, for example. So let me connect that here. So with this 2-node, I can basically translate this into this shader. And just to give you some glimpse of what it looks like, what is generated. So this is basically now all the shader code that all these nodes are built. So we have the different inputs. You have a function that is called, yeah. So it really, shader is more like low-level virtual whatever. You don't not only want to see this, but this is something the shader compiler can compile, and that works in the shader. Okay, so far so good. We leave now the simple level of it and get into some more advanced stuff. As said, I will represent like ray marching and compute shaders, compute shader-based particle systems. So let's start with ray marching. So we use this ray march module, and we create a window. And now we connect this ray marcher to this window. Still, we don't see anything because we do not have fed anything into the ray marcher. And so this is one thing now that many visual programming languages do not provide, higher level functions. And this is like a really important ingredient if you want to work with shaders. So with this delegate, we can now create a function. And this function will represent a signed distance field that you can pass to the ray marcher. So the ray marcher actually can do its job. And so we have a lot of snippets for different kinds of SDF that you can combine. So now I plug in here the torus SDF. And here you see there's the ray march torus. Yeah. If we look into the ray marcher, that's actually also just nodes. So just to give you an idea of how complex systems you can build with views, the ray marcher is not a predefined kind of shader, but it's also a patched thing. So this is kind of what the March function would look like in GLSL or HLSL. And this is basically how it's patched. Yeah. So you can patch for loops. You have if regions. All of these are shader patches. Yeah, and you can get really low level and build your systems, which you do not always want to do. But by building these systems, they are way more interoperable than if these would be predefined shader modules, which would be programmed. Yeah, let's come back to this. So in here, we can also use a noise now that we basically combine with the torus. So we use the combine SDF node and difference to basically cut out the noise from the torus. So because this distorts the science distance field, we need to multiply the output of this scalar to remove some artifacts which we have in there. And we will also increase the frequency of the noise to get into this torus. We also will make this one a bit bigger. Something like this. Yeah, and we will animate the noise. So we take a stopwatch, multiply this, put it in here. Yeah, we need to turn the stopwatch on, and now you see this animated noise applied onto the torus. Yeah. So one thing is now we have this shape, but we also want to render it more colorful. Yeah, so we want to use the same noise that we apply into our SDF. We also want to apply it into the material. Yeah. So how can we do this? First, we switch the ray marcher to another ray marcher, which is the material ray marcher, and this one uses the material system of the Stride rendering engine, which powers like the rendering inside V4. So now you see a bit more quality, shadows, ambient occlusion on top. This is now what the Stride rendering engine provides. And to control this material, we now create a PBR material that we plug into our ray marcher. And in the next step, we want to color our SDF. So I don't know who knows the OK Lab color space. I think it's a nice color space because it's a bit more optimized for human perception than the ordinary HSV. We apply this on top. I turn off the post FX here for now. Yeah, and with this with this theta control, we can now, it's similar to HSV, yeah, but it's, like I said, more human perception control. But now we want to control this with noise, and we want to pass the noise into our SDF, but we also want to pass it into the material. And so the cool thing is now with these higher level functions, we can now put the noise into a function that we call one time into the ray marcher, and the other thing is to call it in our material pipeline. So I forward the input position into the noise and output this here. Let me drag that up a bit. So, and now to call this, we need an invoke. And we pass the noise over here. We take this input, and now basically we do the same thing than before, but we call the noise using this function. And the output we put in here. So it's still compiling the shader, but it's the same thing than before. And now we can use the same function in the same setup, like with the stopwatch and the frequency in our material. To do this, we need to know the position. So in the PBR material, we use a so-called semantic. People who know, who maybe have written GLSL shader know what I'm talking about. So these are predefined variables that you can use in the shader pipeline. And now we will use this XYZ here. So the ray marcher makes sure that the correct position from the ray marching gets written as semantic into the shader, and we can now use that to pick it up. And now we will call again the function, but now from another shader. So this one goes in here, and here comes a noise value, and we plug this one in here. And now we have the noise applied onto a ray marcher as material. Yeah, so this approach is really quite flexible to connect anything anywhere. Yeah, and it's really up to you, like what you do. Also, any input here, what you see is shader node, float 32. So like for example here the metalness, we can control this with a simple float value. Yeah, I can boost that, so now we see this more metal kind of look. But you can at any time control it also with some shader stuff. So you can pull another noise there. Yeah. And also, for example, in the noise here, like as I did before, you can put in another noise to do domain distortion. You can put another noise on that noise to do two-level domain distortion. You can put FBM nodes on top to have multiple octaves. So there are a lot of modules, and you can connect them anywhere at any time. Yeah, so this makes it like really flexible. Yeah, one last thing to the ray marcher. Let's add a plane here on the background. So we take another combine node. And now we combine the noise here and the plane there with a union round, which basically is a smooth combine. This is a smoothing. Now we connect it. Now let's turn the position. We put the domain into the plane here so that it's sampled by that domain. Now we put our, yeah, this is another thing. So the preview also works here for the SDFs. So you cannot, like what I did before with the shaders, you can also do this here in the SDFs. And so we can look, okay, what does the SDF look like here after the combine? Yeah, what does look the plane like, and what does that look like the combine? Yeah, and so you can, because the shader is always generated, you can generate any in-between step in your shader basically, and by that follow your pipeline, and you know what happens where. This does not work at all time, yeah, but we try to make it work most of the time. So we put this in. So this is now the shader compilation. With the material pipeline, it takes a bit longer. Yeah, but now we have the same material applied here. That invoke goes in here. Let's drag the plane a bit down and increase that one. Yeah, so something like this. So now we see here, we get our torus with a noise, and that gets smoothly combined with a plane. So I guess guys of you know ray marching, so I love it because it's such a flexible system, very more flexible than geometry. Yeah, in terms of how fluid and integrated you can build stuff and put noises on top. Yeah, and it's just basically you render every pixel, so you can zoom in and in and in, and resolution always adjusts. Yeah, because you basically calculate every pixel. It's pretty cool. Okay, so that would be one part that I think Fuse can do pretty well, which is ray marching. Yeah. So now I want to show you the compute system. The compute system This basically gives you access to compute shading. And it not only allows you to patch compute shaders, but it also takes over resource management. Because one thing you want to do is you need a resource. So in that case, we create a structured buffer. Structured buffer resource. So this will contain the data of our particles. So we have now 100,000 particles. Yeah. And now I create a group compute stage. So basically a compute stage in Fuse is a compute shader plus resource management. Yeah. What does that mean? You do not need to take care of your structured buffer manually, and the attributes, Fuse is doing that for you. So we connect this group here to the compute system, and we connect this structured buffer resource to this group. If you connect it here, that means anything that gets connected to this group, any compute shader, will operate on this resource. I know it's a bit technical. I hope we dive through that. And we get to some more pleasant visual things also towards the end. So in the system, we have an emission stage. So basically emit the particles. Now we need to restart one time. And now we can look what is inside the structured buffer resource. So we see the attributes here. So we see there is an attribute age of type float and an attribute lifetime. So the emission stage is kind of connecting these kind of attributes, so they are in the system. And in the next step, we're gonna build a probability emitter to actually emit particles. And when I collect this, and there's a node set common attributes, and connect this. So now you see we added just a lot of more attributes here. So we come with a position, velocity, color, size, and other kind of particle attributes. Yeah. You can also create custom attributes, and they will all be added to this buffer. So you do not need to adjust the shader or the buffer itself. The system is doing that for you, which is quite handy. So now let's emit particles and draw them. So we have this disk random. So there are different kind of random nodes which just create random positions. So we will connect this one here to the position. We will also add a simulation stage which will move the particles and advance their age. So just a quick glimpse inside one of these nodes. Again, everything here inside is patched nodes. Yeah, so it's really a complex system. So we are already quite high level, but with all this Atomar stuff I showed you before, you can already build this kind of high level nodes and make sure you can really connect everything. I will take a buffer to entity. So what this node is doing, it takes this buffer and basically converts it into a mesh, and it takes all the attributes and converts them to vertex elements. So with the same kind of attributes you're using in the compute shader, you can now use them in the draw shader because they are already translated internal. Yeah. So this would be another step you would otherwise have to do manually to connect the data from the compute shader in the drawing. Yeah. It's hard to squeeze this all in such a short talk, but I hope you kind of get it. So we will take the sphere imposter node now to render our particles. And now we use the position of the particle. So here we have this attribute. We also have nodes like isAlive to check actually should I use that particle to be drawn. If it's not alive, I will skip the rendering. Now let me connect that one to the render output of my window. So I use a group node to put these two outputs together. And I take the So, and here we have these particles with the disk random aligned there. So now we also want to add some velocity. So we take the tangent of the disk random as velocity vector. So we connect that here. Now you see the particles are moved away from the disk with a tangent on that disk. Yeah. Yeah, now we basically want to play with views, yeah, like this interconnectivity I was talking all about, yeah. So let's now bring in a noise here. 3D vector. This one. So when we take the position we actually get from the disk, feed this noise in, and use this noise. We scale it from, because it's from -1 to 0, 1, we scale it. We normalize it basically with this node. We add an other multiplier on top. And now we use this one to scale our velocity vector here. So this one needs to be added here. Change the frequency maybe a bit higher. And again, we add a stopwatch to animate our noise. So I guess you already saw some difference to TouchDesigner. It's way more modular, way more nodes, yeah, which can get nerve-wracking. So you sometimes think, probably already, yeah, but we have just one top or chop or whatever, which does it all. You need to put in 5 nodes. Yeah, I know. Again, I love TouchDesigner. I'm not using it, yeah, but I also love this one. So it's different possibilities, yeah. So I think it's good to open up maybe sometimes. So no, for sure, it's not a discussion on what system is better. They are both awesome, yeah, for sure. Highly respect, yeah, to what you guys have built. It's all better than Unity. Yeah, so we animate the noise. We still need to start the stopwatch. And in the next step, we will now also control the probability here of our emitter. So this is basically the probability which with a new particle is emitted from all the empty ones. So we copy these multipliers here. Oops. Sorry. I always take eye care just to get to sleep better at night. Yes. So we were there. We take the probability here. Oh, take the noise there. Probability here. So now we're also modulating the amount of emission with the noise. So it's sometimes more and sometimes less. So as I'm almost out of time, I will just do the last connection here on now how to bring those two things together. So I still have my ray marcher, which I will turn on now. So first thing is we see the particles are not matching here. So we change the orientation of the particles from the disk random from xy to xz. So now it's almost aligning with my torus here. What else? Yeah, I need to open up the noise a bit more. So I put an add here to shift a bit through the usage of the noise sign distance field. Basically what I will do now is to expand the noise. So now you see it's less structure. Yeah, so I can completely close it, or now with this thing more open it. And now I will add a collider to the simulation stage. So this is collision. Add this here, and now we add an SDF collider. And take the same SDF function that we have here for ray marching and use this one for collision. So like we did it with the noise, we can take the same SDF now to integrate this into our particle system. So we need to add a bit radius for this to work. And we will add some bounds. We will add some more kind of thing here. And maybe to make this more interesting, as one last step, we will add some rotation. So we take xz minus y. So these are kind of the swizzle nodes to access our coordinate data here. And this is a 2D rotation, so we just apply it to xy. After that, we will reconnect them. So we take an xz plus y. So we take the rotated xz, leave the y untouched, put this in here, and take our rotated input. Sorry, the patch gets messy. But it would take me longer to clean it up than to patch it, basically. I guess you know, maybe you know that from Touch, but in V4 it's always like that. Yeah, and let's take this stopwatch to rotate the noise. So it takes again to compile this. That's way too fast, of course. Yeah, so that's how far I could get. I hope you see more like how you can interconnect things, yeah. And like with half an hour more, basically in the train, I did the same today, pretty much the same timing, and then I thought, fuck, crap, it takes too long, yeah. So now, like fast forward, I show you the present. Like if I would have another half hour. Well, let's save this still. We go in here on the so this is like here I could put a bit more focus on how the particles to look, like the noise is a bit more complex and the rendering. But basically what I showed you before is kind of the scaffold and the idea, yeah, which I now used here, yeah. So to put this all together, so again we have the noise region here with the rotation. I replaced this noise I had before with a wave noise, which has more octaves, is sine based. Yeah, SDF is pretty much the same. This OK lab thing is a bit more complex. So basically what you see here, to get more contrast to the particles, I just added this color here to the steeper areas of the noise. Yeah. And this is a bit the fun then. You can combine these low-level nodes to apply calculation really kind of granular where you need it, but you take these higher level functions to get like noise and complex stuff and build it together, or the ray marcher. Yeah, so you can mix and match how you need it. Yeah. Yeah, and also the particle system, I applied some more simulation. So there is a directional force that drags the particle down. So, and some FBM noise, so to put some noise also force on top, which is blend out over the age. So at the beginning you have a lot of noise, and then while the particles get older, they lose that noise, yeah, to just float around. Yeah, that's pretty much it.
Christian, thank you very much for this insight in a strange and dark world.
I can make it white also, then it's less dark.
It's just such a contrast to the presentation before. Very fascinating for me. I mean, I don't know how to write GLSL shaders, and this is similarly alien. I wonder, because we often get asked, especially from beginners, should I go for TouchDesigner, should I go for V4? You know both of them. What would be your answer? Like, where do each have their strengths?
Yeah, I would say for sure strength of touch is community. Like if you look on YouTube, there's so much touch and not so much V4, yeah. So that even I as a V4 user look for inspiration there, yeah, and it's highly appreciated. What else I like, if you look at the node set, it's like, I listed them, it's 500 nodes, I don't know, correct me if I'm wrong, but it's more like hundreds. In VL it's like thousands, yeah. So it's way more confusing to find this entry point there. But that's maybe also something where I would look into with Fuse to get more high-level nodes. So like if you are not an advanced user, you can still do a lot of stuff, yeah, but not need to get too far in details. But that is what I would say, community and higher-level node set, yeah.
Interesting. Do you have questions for Christian?
Hey, so compared to a lot of the node-based real-time stuff that we all know, like a lot of us here, I guess, use Houdini or Touch or whatever. This seems so much more complicated in terms of the node graphs. You've got like a lot of maths going on. You've got a lot of color math and a lot of vector math going on. Is this just like a cut down, easier way of getting into GLSL coding? Like, is this like basically a shader coding environment?
Yeah, I would say so. So for me, I have written shaders like a lot of years. Like I've written shaders for longer than I've patched them. Yeah, so I'm used to this kind of granularity, and I also want to have that available. Yeah, but as I said, like the outlook is now, like for the noise would be one example. The output of the noise, it can create whirly noise, simplex noise, so a lot of different noises, kind of what you know from your noise top or chop, I don't know, but this really nice noise thing, yeah. But still you can use it more granular level if you want to have more control. And building all this system, for me it was important to get this low level thing right, because a lot of tools offer a nice high level perspective, but if you want to get more into it, kind of like in Houdini maybe, like in Cinema you cannot, in Houdini you can, yeah. And this is the idea here. I want to make sure you can do it. That's even why I forced myself to patch the Ray Marcher. Of course I could have maybe written it, but I wanted to make sure you can build those stuff by patch and not take a shortcut and know it's working. Yeah, and this is now the next step basically to build this more high level stuff, yeah, that you not always need to patch everything, but that's also kind of to switch maybe a bit how you use V4 in general, yeah, so that's also in discussion.
Hi. I'd like to add something onto the topic of comparing V4 and TouchDesigner. So I'm a long-term V4 user, and I think when it comes to TouchDesigner roundtables or the general output TouchDesigner provides, it's mostly around visual output, everything that you can somehow tell its aesthetics or whatever. But V4 is way more than that. It's basically a visual representation of C# and the .NET framework. So basically, you can basically do actual serious software engineering in V4. You can build, you can do object-oriented programming, which I don't know. I never used TouchDesigner, but I think it doesn't provide the same tool set around that. So you can build huge systems. So while this is super complex, this is just the tip of the iceberg. So if you want to get into some serious software engineering, V4 got you covered. Okay, sorry.
Maybe to finish up that round of questions would be, do you see a bridge between those two? Would there be a use case where I say, well, could be interesting to patch a shader in there and then use it in TouchDesigner? Or, I mean, in a team effort? Is there interconnectivity?
Yeah, so for me, interconnectivity, again, is more on high-level things, like see what you guys built in Touch, understand the concepts, which is not so hard if you did it like a couple of years, yeah, and then transfer this, because this is what it is about, yeah, it is about take this noise, apply it here, do this kind of calculation, and then that's the output, yeah, and if you do it in V4 or in Touch, in the end doesn't matter, it's about getting these things together, yeah. And then it can be Touch, it can be Unity, it can be Shader Toy. So a lot of stuff comes from Shader Toy, actually, like in ray marching, you know, that's a high inspiration. To connect it, yeah, I would see it more on this level. What I would like to get to with Fuse is maybe more make it an open kind of programming language, which you can use in other systems as well. I'm not sure how well it translates to TouchDesigner, but it could be maybe translated to Unity or Godot or other things, and then be used there. So that's stuff I'm thinking about, but of course it would be a big step because you do not have the visual programming language already established like you have that in V4.
Furthering, but to a different level of interconnectivity, is there input and output from external sources? And
yes, so basically in the compute world you have these buffers and you can feed in other data as buffer. So like the simple part, like to put stuff here on the GPU, is have these input pins here where I put a vector 3 from the CPU on the GPU. Yeah, is that what you mean with getting data in?
Not at all, but I appreciate the answer.
Okay.
I meant more like hardware, external hardware controllers. How can you control Fuse?
Yes. Yeah, basically like this. You take this control data, there are libraries in VL, and you transfer this data into a buffer. Buffer meaning kind of array, but on the GPU. And then you can basically load your 200, 2000, whatever kind of values you have into the GPU and access them in your particle system or wherever. Yeah. So this is not covered by Fuse, but it is covered by other systems, and Fuse has kind of bridges to get this in.
Yeah, all right, you next. I just wanted to ask, do you have like D3 or disguise blocks? Like, does it run on media servers for concert visuals?
No. That would be also for the V4 guys to do, yeah? Yeah.
Yeah, just to catch up on your question. So we basically you maybe have heard of NuGet, which is a C#.NET thing, and basically you can pull in whatever library that has been written in C# and use it straight away in VL. And so it's open to all sorts of protocols. We have MediaPipe, LeapMotion, VR, whatever. You can control robotic arms, projections, lights, DMX, ArtNet, whatever. So it's got it all.
Yeah, you're doing a way better job of promoting V4.
Hannes hat jetzt mal für eine, it's qualified for a free V4 license. No, sorry, no more questions. We only have 10 minutes for you all to go to the toilet, get a beer before we have the next speaker. And don't make it so hard for me to come back.
Thank you. Very appreciate it.
third new face for the evening. We had Stefan, David, and I thought I would step up here and also bask in the spotlight. For those of you who don't know me, my name is Harshini. I'm the program manager for the NodeInstitute. It's wonderful to have our roundtable, our monthly roundtable here, and see so many new faces. So if you haven't had a chance to come up to me and say hi, please do. I would love to, hi. I would love to meet you. And for those coming back, it's nice to see all of you here. I just want to say thank you to our first few speakers, Ricardo Torresi, Jan Choi. Thank you for kickstarting us and also welcoming us into your space. Jan, I know you were also here. You flew in from London to be with us. So thank you for that. And to Christian, who just did his talk and took the train as well to be here with us today. Thank you so much. Before introducing our next speaker, I just want to say, because I'm the program manager of the NodeInstitute, so I have to tell you about things. Our summer season has just started with the NodeInstitute, and we have Stefan Krause's Creative Masterclass in collaboration with Studio 1111 that just started, which is creating content in immersive spaces. And our TouchDesigner Beginners course is about to start next week, alongside V4 beginners as well. So if Christian's talk inspired you, confused you, intrigued you, made you curious, V4 beginners will start next week on April 29th. And for those in the room already familiar with V4, we have our intermediate season lined up, and Christian will also lead a whole series of courses just dedicated to Fuse. So you can find all of that on our website at thenodeinstitute.org, or follow us on Instagram. I'm doing the social media thing. So chances are, if you have questions, you can DM us straight from there or email us, and I will try my best to respond to you. And tomorrow we have an info session online. So if you have more questions, you want to talk to me, you have questions about enrollment, you can do that. Our next speaker, wait, full stop, breathe. Our next speaker is Lyell Hintz. Some of you might know him as .simulate, and I'm super excited that we have him as part of our summer season TouchDesigner Intermediates. He'll be teaching a class on integrating AI into TouchDesigner, which is also what his talk is going to give us a little bit of an insight about right now. So thank you, Lyell. You're joining us from Brooklyn. Thank you for being online with us today. And thanks, everyone in the room. Applause for Lyell. Yeah.
Thank you, thank you. Yeah, first off, thanks for the NodeInstitute. I'm gonna stay on camera for a second and go to the screen share presentation mode, but yeah, just want to without further ado, I'm going to try to share my screen. Oh, nice, it worked. So I already said hey, but I am Lyell, also known as .simulate online and the social medias. A bit about me, I studied theater in college, graduated a couple years before the pandemic. I am not a kind of developer by trade, more of on the art side, but always have been very technically focused, with graphic design always being like kind of a passion and a side project of mine. Always was also in a band throughout college, and that was kind of, both of those things were like drivers on the side of investing time and energy into learning these kind of like technically more challenging things, while I also studied like directing and writing primarily, and then after school got a lot of design jobs with sound design and projection design, and that was in Philadelphia. This is a bit about kind of the discovery of TouchDesigner. I discovered it in 2020, probably about a week into the pandemic. I had been using After Effects and MadMapper to formulate and map and create some of these almost interactive installations that I was working with, and also doing a lot of theater design within some shows and trying to get my foot in the door that way. And also, like I said, experimenting specifically with Ableton for sound design. Ableton was a big driver of like an instrument was really interesting for me. And yeah, I've found from a lot of people that use TouchDesigner now or have in the past or whatever, a lot of people come from a bit of a music background, but also like a multifaceted arts approach background. So that is also kind of where I come from. At the beginning of the pandemic, I got really into, can I go back? Yeah. And MadMapper, like I said, but I really enjoyed how all of the logic was laid out directly in front of me and I could see everything and actually understand what I had been doing without like hitting undo and redo a bunch. I ended up diving full deep and kind of being quote unquote self-taught, but by following tutorials. Nine Between was really inspiring with his kind of daily breakdowns of these Houdini challenges that the Side Effects hosted. First one being Hulai, which was in, I think, July of 2020, and then Mardini the next 2 years, which I participated in. And then also TouchDesigner with Electronaut, Node of the Flying Ball, and Noon's Image, which I'm sure you are all at least somewhat familiar with. And simulating things within almost just on a flat plane, and I would build something that would kind of move on its own, and then with either rigid body sims or Vellum soft bodies and stuff, I could kind of let it live in the world. And it was really interesting to set those parameters, bake it out. I also was interested in making stuff look pretty, but that kind of fell by the wayside a lot of the times. I got really into procedural system design. Like this one on the left was like a crowd of ants, but what I mostly focused on when building this project was actually just building the full crowd simulation and making sure that it would traverse across like geometry that wasn't flat, and then it would be able to go up and around the head, which is a bit of a technical challenge. And then, yeah, these are just kind of some of those Mardini experiments. Like I said, all of these are on my learning more about TouchDesigner and developing with it, and also using it as a development platform and building within it. And then furthermore, building tools with it for other people. Most of, I guess, what I call these tools come about with me working with some other process outside of TouchDesigner. And at least for the past 2 years, I've pretty much constantly wanted to get that thing within TouchDesigner. So figuring out how to get comfortable with connecting with APIs and reading documentation, also figuring out what ChatGPT can be useful and what it is not useful at, and debugging and all of those problems that come along the way. Also, I've been doing a lot of media design and exploration within AI generative tools. This takes the form of images with Stable Diffusion, but also video and music as well, a little bit. Although I think the AI generated music is still a little bit limited as in terms of like use case, but it is really fun. Going over a little bit of like early explorations with AI, like before Stable Diffusion, there were a bunch of things that, bunch of Google Colab notebooks that I would stumble upon and try to parse what the heck those parameters even meant. a lot of them were basically feedback loops where it would create an image and then iteratively do a image to image pass or just a slight denoised. It depended on the actual architecture of the model, but it would basically move forward. And then most of these, I guess, or PyTie and Centipede and Disco Diffusion both had camera controls that you could type in and keyframe a little bit. So in early 2022, I built a simple TouchDesigner system that was like, it was just a project. It wasn't even like wrapped or anything, but it recorded chops and then turned that into DAT data for the keyframes for the format for these two diffusion engines. So I was doing a little bit of like audio reactive zoom on the beat with these super early AI stuff, but it wasn't very promising. I also searched for video evidence of this and couldn't find it because Google Drive is a bit of a mess and I might have deleted those folders. I hope not, but also doing explorations with DALL-E, which was kind of the first quote unquote like text to image model that was really able to diffuse things that weren't kind of like these three on the bottom right, which are very abstract and almost GAN-like and potentially very GAN-based in the architecture. Not actually too sure about that. And then also with playwriting and stuff, I was kind of aware of these LLM models. I think even going back to like GPT-2, which I believe was open source or partially open source. And then these are OpenAI models, but DaVinci 2 and GPT-3, not GPT 3.5, but these are both things that you would play around with in the OpenAI playground. And I remember like the first thing I tried was I basically took one of my plays and tried to like extend the scene and see just what the heck the AI would imagine. And I remember it being really bad, of course, but it was still really interesting to do. These are some DALL-E mini experiments. I guess I've always been interested in kind of like recreating these UIs of these programs that I'm learning also with these AI generators. This photo's like cropped weird. Oh geez. I hit the back button on my mouse. All right, this doesn't matter. View only, okay. This left one is, I think, what DALL-E Mini, which is a like open source version that would spit out a grid of images, and it was really quick, so it was really fun. DALL-E Mini was imagining this was the Houdini interface, and I think this top right one was Blender, and then this one, which is a little squished, but it, I believe, was flip simulations, which was I was also struggling and trying to learn at the time. Or at this point, I had definitely done some pretty significant flip simulations. And then big news of the whole year that year for at least like the AI image generation models was definitely Stable Diffusion in August of 2022. And I remember it dropping with just a GitHub repo, and there was some code that you could run. And I was, like I said, I don't have much of a developer background. So I was like, cool. All right, I'm going to figure out how to run this code. What do I know that runs code? TouchDesigner. I've definitely written some Python in that. So I was like, I'm going to run Stable Diffusion TouchDesigner, which was probably a pretty silly choice if I actually kind of knew what I was doing. But the way that I ended up making the initial 1.5 model work was I built just a UI that let me type in the parameters I wanted in like a way that I felt more comfortable with. And then this button at the bottom would simply add the correctly formatted prompt to my UI.clipboard. And then it would also open the entire Stable Diffusion process. So I could set the prompts and hit copy and prompt trigger. And then it would take a minute for the model to load up. And then I could go to the like command prompt window, copy and paste in my prompt and hit enter and wait 20 seconds for the image to come back. That was fun. It was super cool. I don't actually remember really making this. I think it was like a 2-day or 24-hour just kind of blackout development session. And I was like, at the end of it, I was like, wow, I have this thing. And I remember sending a video to someone. I was just like, oh, I think I got stable diffusion inside of TouchDesigner. I'm like, no, not really. I made a UI that could build a prompt command that I can copy, but still very fun. And this was very encouraging for me as far as like kind of being able to build something within TouchDesigner to access a tool that I had not previously, I guess, been able to access. Yes, it had just been released, but also when it was released, the model wasn't really like today where there's like 20 sites that's hosting an open model and like has free credits. So if you just search it, you can probably like get a fairly nice UI somewhere on the web. This was a bit more early days, so I was pretty happy that I got here. Some other just fun TouchDesigner related things to show off. This is like the end of like the prepped thing, and then I'm going to move into just like moving around in a TouchDesigner network and showing more. But this is like a LoRa that I trained on a bunch of crazy networks that I've built. Sometimes when I'm especially deving out just visual systems or installations and stuff, my networks tend to be sprawling. And then I condense and clean and pack things into smaller components once I've like kind of identified what functionality needs to be packed where. But I have a lot of projects that I can open and take a bunch of crazy screenshots of networks. So I trained a LoRa and the results are really fun. And it's something that I've kind of used and played with, and also yeah, just used as kind of like almost a style in a sense now, informed by the actual UI of the program I'm working in, which is fun. But let's leave the Google Slides and go into something that makes a little more sense to me. Yeah, I got, what should I? So I've been making a lot of tools. These are kind of like the current ones that I have. They have at this point a bit of almost a format. I have discovered an ability to structure the development of this a lot more than I did when I was first just building these things. We have in a different project, the first tool that I made was with connecting to Automatic 1111. And that was really the first like API that I had actually connected to more than calling one simple hard-coded value. And the process of that was a huge learning curve as far as how you would actually build something out like this. These are kind of like the internals of various versions throughout the process. And at a certain point, I had so many different little tiny things talking to each other. And a lot of these were inputs, and a lot of them were necessary, but especially a couple versions ago, like all of this contained all of the logic that would collect the parameters, or this contained all the logic that collected the parameters, and this contained all the logic that got when images were ready on the server and when images weren't ready. And I was like modularizing these, and they were it was nice because they were in nodes, but then when I put out this tool and there was a lot of people that were using it and finding problems and things that were broken, which is extremely helpful. And then sometimes or occasionally I would get a message that's like, hey, have you ever heard of extension classes? And I was like, oh yeah, kind of. And I inquired a little more information, then looked up more about the documentation and was like, oh, that's really cool. I don't have to spread like all of these little parse code. Like I don't need to have a parameter exec down here doing 14 different functions. I can pack all of that into one code block and call that from different areas of the network. But all of these things are things that I've discovered along the way, specifically mostly with building this tool. And then it got to a point where I needed to transfer all of this logic, which was in modular little nodes inside, to the extension class, which is, I think, right there. I think I actually released this version once and I just had all of these nodes as archive. I think they're bypassed, but obviously the screenshot doesn't show that much detail. And then slowly but surely, I guess this is where it kind of ended up, which this looks a lot more familiar to me now because this is pretty much the logic flow of what most of my current operators are doing. To kind of go over that high level ish, the logic is baked in the extension class. And then when you call the API or the external call, because most of the processes that I'm building out are directly talking with things outside of TouchDesigner and then calling it back in, with relying heavily on this TD async IO component, which is pretty incredible for what it can do since TouchDesigner is single threaded. There's a couple, I've slightly modified it. It is normally a global component, but I have kind of turned off some of those capabilities and use it specifically within the operator. But you'll call the API and then things are stored in a table, and then you're able to look through those tables, and it would maybe make it a little more sense to go back to the other project. So this is a music gen tool, which I guess you can kind of see a similar, I have this like kind of long line of DATs, which is parsing collecting all the generation data. This one has some fun things I added where you can search, make sure this isn't playing. You can search by highest rated. So I've actually got, I've got what, 700 outputs in here, and about 150 of them are rated. So especially with this music stuff, when you're generating like 60 seconds of audio, it's really hard to remember what all of these things kind of sound like. So just adding that rating slider in there was a handy way to kind of keep track of the generations. But what time is it about? Where am I at on that? Because I feel like I don't want to just start getting too rambly. Zoom out. Then stream diffusion, which is pretty cool, which major props to the stream diffusion repo, specifically, I guess, the screen example, which is what my Google Chrome went to, which is what I based the first version and the current version of, like the main code block that drives it. But this was a paper and GitHub that came out in late December. They did several key features here to speed up the diffusion process. And I think they did something, it's like 60 times the normal diffusers pipeline, but it is using diffusers, which makes it pretty accessible for adding more functionality to it. And the repo itself includes a couple different demos. There's like this kind of rapid fire text image demo. Actually, I don't know if this is actually a demo from the repo, but this one is the screen example, which uses some screen recording Python library to take a little section of your screen, send it into Stream Diffusion, and send it out. And so looking at that, I thought that is definitely something that would be handy to have in Touch. A couple things that I added or changed and like kind of forked onto the repo is, maybe I'll just start my little stream server so it's actually doing something. I've been adding these sequence parameters. New TouchDesigner 2023 feature is you can add these sequence parameters, and I have used them in order to create like multiple prompts. So if I was to reset this, just go like blue dog with hat. Oh, Jesus, keyboard. I've noticed that my keyboard sometimes freaks out when I'm streaming on stuff, but keep it at weight of 1. This will allow just kind of mixing the prompts. Pizza, sure. And it's not perfect because the prompt mixing it's not necessarily doing the same thing that you would prompt mix with, I guess, like the parentheses weight method within other diffusion pipelines. This is a bit more optimized for real time. And this is also an area that I see a lot of opportunity to add and further like add coherency within the model, is both blending between these prompts, but also adding proper prompt weighting. And also in the seed blocks, I've got kind of this seed travel effect going. So the prompts are not actually changing, but the image is constantly evolving, and I'm kind of rotating through these seeds. If you see the bottom one, or to create the weights and then merging and doing some prompts. I also have this prompt table, which I'm doing a similar thing to travel and traverse through the prompts. But one interesting thing that I'm reminding myself to show is the ability to actually use Stream Diffusion as kind of a feedback loop. So let me set these prompt blocks. I can actually plug this cache into the front, and you will get it feedbacking on itself, almost deforum style, if you are familiar with that, which is something that I also discovered right after discovering the first Stable Diffusion. I was planning on talking about a little bit, but so this is kind of feedbacking on itself, and the image is evolving over time, which it's not perfect if you go almost at a lower denoise value because of the distilled model, but it still does kind of work. But if you find something that also my prompts and seeds are changing pretty rapidly, this is not really a tested setup. If I was to add something like a transform, I could start then zooming in on this image slightly. Yeah, you get it. You see it a little bit there. If I stopped the prompt from traveling as much and locked it down, well, now we got nothing, but kind of give it a jostle there. But this is this sort of using Stream Diffusion live as within a feedback loop is really exciting. And the reason that the latency is allowing for this is I recently stopped using NDI and Spout and then just switched to creating a shared memory buffer between the Stream Diffusion Python process and TouchDesigner. But yeah, that's a little bit about Stream Diffusion. I don't know. Experiments, some other AI stuff. These are like some ControlNet fun, tasty looks. I am not sure about the frame rate. Oh, the frame rate looks, if I check my feed, you haven't been seeing much. Yeah, it's kind of hard to show these when I check the actual feed. Maybe, oh, another thing I've created is this Python manager, which is a way to pip install, pip update, pip uninstall, and it's all based in virtual environments. And it's still something I'm working on. I really want to make it work on Mac and then like just put it out there open. But you can hit this set Python executable and it'll search through your computer and find all the Python paths. You can also, if you're creating a virtual environment for something like Stream Diffusion, which doesn't run on 3.11, you can select your specific Python path here. And then if I was to delete this, or delete the operator, delete the base folder and the parameter, create the VNV, I can just create a test folder here. And this will lock my TouchDesigner operator, and somewhere there's a, somewhere there's a command prompt popping up and making a virtual environment. So now that TouchDesigner project popped back, I can list my current packages, and I have pip and setup tools. And if I wanted, for example, to install the OpenAI library, I can just hit pip install there. And I think I have a toggle for locking the project. And that's why this project is locked. But since it's an external virtual environment, it can just, block threads. So if I was to, I could list, this always blocks the thread because it needs to read it back. Now you can see the libraries that I've installed. Another thing I recently added, which is fun, is this run subprocess function, which is like name TBD, I don't know. But this allows you to take any sort of like script, just because I don't have any other better ideas. Let's go. Oh, I just didn't print hello. Hello TD. And then within this, let's see if I can actually do this. Jesus. I can go, wow.
So while you're typing this in, I would suggest that we maybe also use this demonstration as the last part of the presentation, if you don't have anything
100%.
Specific. And in the same time, I'm asking here into the audience if there are questions. If not, maybe prepare your questions, and then when the external sub-process run is demonstrated, we can check the questions in the room.
Yeah. For a more reliable demonstration of that, I will just show off this thing I made the other day, which is a text to or speech to text real-time transcriber. But the way that I made this work is this is just the full Python script. And instead of setting up a web server within TouchDesigner and trying to stream audio and do all of that, I, within my extension class, just run this dat within the Python manager inside of the virtual environment specifically. So I also know that it has the things. I can't use the U shortcut to go up when I'm screen recording. That's odd. But so if I launch this, now it's on and I can hit the record, and yeah, it should be on the right input. And if I start talking now, it should be, yeah, it is showing what I'm saying in real time relatively, and it kind of breaks it up into chunks, and I can then stop talking, and then I'm sending it to a ChatGPT conversation, and yep, yeah, thanks buddy, it's definitely working. All right, goodbye. And this is the Grok API service, which is like lightning quick, and using Meta's new, this is just the 8B, but you can also use the 70 billion parameter model. And if I zoom into like my little UI, it's going to be like just a bunch of me testing this. But I've got a little UI, which is kind of like a ChatGPT interface. And also, like most of my things, it has a full extension class. So it ideally should be pretty interfaceable without using the UI or using the parameters. But this is another fun thing that I've thrown together. And yeah, I think that's like kind of like about where I could end it. Maybe if anyone has any questions or thoughts. One other thing also, I put this out as like available for everyone for going to be fully open soon, unless that happened like today and I just haven't been checking the news. But in case anyone wants to kind of take a peek at some of the tools that I've made without maybe subscribing to my Patreon, I do have some other, yeah, like you can see a bit. Shows a bit of that process. But yeah, I can.
Hi, I have a question for you. My name's Kelly. First of all, I want to say thank you. These tools that you're making to incorporate AI into TouchDesigner are probably going to be some of the most like widely used and influential custom operators that the community's seen in a while. I see a huge ground for it, so thank you for that. Out of curiosity, what do you want to see from TouchDesigner to integrate AI more seamlessly into the software?
I feel like I'm mostly working with it. And a lot of the things that I found how to do, like I said at the beginning, like I don't come from like much of a development background. So most of the tricks in my toolbox have been tested and discovered within TouchDesigner. I do definitely think that multi-threading would be like incredible. and kind of like what I'm doing with this Python manager could be fully handled. Yeah, I'm very excited. I will be in Berlin for the TD Berlin event, so I'm really excited to kind of see some new features that they've got maybe going. And look at that. I can share my screen. That's maybe a little more interesting. Frozen face. Now it's TouchDesigner. That's fun.
Okay, so one question here. Could you maybe repeat the last part, because we have some little internet troubles here. So you sometimes drop out for 1 or 2 sentences. So maybe repeat the last 2 sentences.
What did I say? What was it? I think if you could repeat the last 2 sentences of what I said, that would be great too. But I think I was saying I'm really excited to be at the TD Berlin event next month, at the end of next month, and hopefully can get to meet a lot of you if you are still in Berlin, and also see maybe some new TouchDesigner features and new tools released by other members of the community that I'm excited about.
Yeah, I think we're also very excited to meet you in person. We're sorry for the dropouts. It wasn't dramatically, but it was a bit happening occasionally. I think we're also quite late with the time, so if we have more questions, now would be the time to ask. Or we just thank Lyell for being with us for this evening. And like I said, we're looking forward to meet you in person. Thank you very much for the time. And thank you all for coming, and thank you Field for having us and hosting us. And as always, I would like to extend a big invitation to anyone to present at the TouchDesigner Roundtable. We had some very professional presentations today, some very deep knowledge has been flashed, but that doesn't mean that it always has to be like that. We're also very open for beginners. Right, so everybody has a story, and every story is interesting, and it's a community event, so it's not only for the professionals to show off, but it's for everybody to share and to learn from each other. So 2 invitations. If you want to invite the TouchDesigner Roundtable to come to your venue or to your agency, talk to us. We're very happy to visit you. And the other invitation is, if you want to present at the TouchDesigner Roundtable, open up to the community, also talk to us, very welcome. I think it's needless to say that we have a few highlights coming up, as in the TouchDesigner event, which is happening on the 21st, 22nd, 23rd, and even bleeds out into the 24th of May, with a lot of international superstars coming to Berlin. There has been a bit of frustration because the tickets for the daytime program are sold out and the waiting list is very long, but these talks will be streamed, so you can watch them online. And I would like to add that we made a lot of worked a lot of connections to make an exciting evening program, the first of which is going to happen in Studio 1111, and part of the VJing, or maybe the whole VJing of this evening, will come from the participants from the course that is actually running, and there's also 2 participants here in the audience. Thank you for coming. And second evening, the 23rd, will take us to Monopol up in Reinickendorf. If you haven't been there, it's exciting, abstract, brutal spaces that lend themselves very much to light art. And our friends from D-Real and our friends from LED Pulse will get together, and the room will be filled with 70 LED volume models, and we will invite everybody who has a ticket or who RSVP'd for that event to connect to this Dragon system and jam on it. I think it's a pretty nice opportunity to get this tech under your fingers. For both of these events, they are free. All you need to do is RSVP on our website. And I hope you're all going to sign up and we're going to have a great time. And the last thing that's going to happen as an extension of the program is going to be a PyTorch workshop with Itzard and Keith. And I have not completely understood what it's about, but the people who understand what it's about, I think for them it's very exciting. And I think it could also be interesting for Lyell, because if I understand it right, it's another way to accelerate this whole communication between the diffusion models and the TouchDesigner. Something like that. Very exciting. If you're the workshop. Yeah, it's in person only.
At the Spatial Media Lab where we were last time for the roundtable, and also after the workshop, you are of course invited to stay and let the whole TouchDesigner event run out basically on a very community basis. But for the workshop itself, you need to RSVP. So just saying, we have very limited space for that.
And we love RSVPs, so please RSVP. Okay, I think that was all the news we have to share, Harshini.
Just because it's also been so wonderful to see so many V4 folks at our roundtable. Next week or the week after, May 3rd, is the V4 meetup at the NodeInstitute, which will happen in person and online. So that's the V4 Worldwide meetup on May 3rd.
And they also have a very nice community, very similar to ours. So it's good to mix and mingle. And Bilea?
There is also an online TouchDesigner meetup this Sunday, the April 28th, on interactivity with 3 lovely speakers. It's going to be on the Music Hackspace Discord, and I'm going to be hosting it. So make sure to also attend that. I think it's going to be a really interesting one. So it's going to be 5 p.m. CEST this Sunday. Thank you.
No, so soon we will not have to spend any single day in the week without TouchDesigner event. Yay! Was there someone who wanted to say something?
Okay, but I think we can also all talk this in person and not...
No, we have microphones. All right. Thank you, Field. Thank you for having us. Thank you, everybody, for coming.
Applause for Lyell.
Yeah, and a final applause for Lyell.